The two guide rails for the elevator shown above each exert a constant friction force of 100 newtons on the elevator car when the elevator car is moving upward with an acceleration of 2 meters per second squared. The pulley has negligible friction and mass. Assume G equals 10 meters per second squared. Part A. On the diagram below, draw and label all forces acting on the elevator car. Identify the source of each force. Alright, so for part A, we're going to have the force of gravity. That's going to be acting in the downward direction on the center of mass of the cart. There's going to be tension from the cable pulling the elevator car upwards, and also the force of friction on both sides of the cart where the cart is touching the rails. Part B, calculate the tension in the cable lifting the 400 kilogram elevator car during an upward acceleration of 2 meters per second squared. Assume G equals 10 meters per second squared. Alright, so for part B, we're going to want to use Newton's second law, which says that the sum of all forces is equal to mass times acceleration. And our cart is only moving in the y direction, so I added the subscripts to make that even more clear. So plugging in all of our y forces, we have a bunch of them. We've got tension in the upward direction, so it's positive. Two forces of friction which are both equal in magnitude, so I just combined them. And the force of gravity also acting downward, so it's negative. Rearranging for t, since that's a variable we're trying to solve for, we get t equals ma plus 2 force of friction plus the force of gravity. Plugging in our numbers, we get that the tension must be exerting 5,000 newtons of force. Part C. Calculate the mass m of the counterweight. Calculate the mass m of the counterweight that it must have to raise the elevator car with an acceleration of 2 meters per second squared. Alright, so let's start by drawing a free body diagram of the counterweight. So that should look something like this, where we just have tension from the cable pulling it upward, but the force of gravity pulling it downward. And something I didn't mention before is that in my first free body diagram, all of the forces going downward sum up to a vector that's shorter than the vector on top. Because the acceleration was in the upward direction, there must be more force acting upward than there is acting downward. And for the counterweight, we have the opposite, because the counterweight is moving down in order to lift the elevator cart up. So the force of gravity must be acting on the counterweight more than the tension force. And of course, we're going to use Newton's second law as well, and we can plug in our y forces for this free body diagram. And our goal is to solve for m, so we want to move our m's onto the same side together, and then we can rearrange and divide by g minus a on both sides, and that will give us our equation for the mass of the counterweight. Plugging in our values for the given acceleration, and we already know the tension in the cable from the other side of the pulley. It's going to be the same tension, and we get that the counterweight must weigh 625 kilograms.